Hello again, everybody, and welcome back. This is the beginning of our chapter on vectors, chapter 3, and it really is going to be kind of an application of what you may have learned in trig, and we're going to be using a lot of sines and cosines and tangents and reference to angles and things like that. So, if you recall, a vector is some sort of a measurement or some sort of a value in a given direction. What I mean by that is this. If you stand at the very center of a town square right here, or it's a good town circle actually, and you say to somebody, hey, where's the library? They say, hey, it's only r miles away, or in this case, r is 0.5 miles. So they say, it's easy, it's only a half a mile away. Go get it. Well, what's the problem? The problem is that they don't tell you what direction. It could be a half mile in pretty much any direction. There's a half mile radius around you that the library could lie on. So if the person was more helpful to you, they would say, oh, okay, well, it is 0.5 miles away at this angle right here, or you might say at this direction. This being a compass coordinate system, that being north, south, east, and then west, they would probably say that it's northwest. So you say, walk northwest for 1/2 mile, and you'll hit the library. That's great. So they give you a vector. They give you a magnitude, an amount that you need to walk, and a certain direction, a very specific direction. Otherwise, you won't hit the library. So vectors can be represented graphically by an arrow. All right. So any kind of arrow like this, it has two values to it. It has a magnitude. It has a certain length. And this vector right here is going to be different, from this vector here. So we'll call this guy A, and we'll call this B right there. They're going to be different in that they have different magnitudes. Now they do have the same of the other values, that is, they have the same direction. They're both pointing towards the right, or we might say in the east direction, or along the x-axis. So the direction is indicated by, of course, the direction of the arrow itself, and the magnitude is indicated by the length of the arrow. And the longer that length, the greater the magnitude. So if you were walking to the library, if there was a longer vector arrow, it would mean that you had to walk a longer distance. So these two vectors right here are only different in that they have different lengths, different magnitudes. All right. However, if I drew a vector right here, okay, in a different location, but the same magnitude and the same direction as vector A, what should I call this? I should call this vector A, because the point here is that arrows having the same direction and the same length, that is, same two properties we just talked about, are going to function as the same vector. You can translate them. You can move them around to different places. It doesn't change the vector itself. The vector, regardless of where it is a certain magnitude and is a certain length. All right, and so we call it that vector right there. So if we look at this little graphic right here, these are all the same vector, even though they're in different places. They're all the same length, it would appear, and they all have the same angle from the x-axis. That angle, so forth, is all the same angle. So we're going to treat them as if they are the same vector. Well, they are the same vector. Okay, so the magnitude is the length of the arrow. But what about direction? How do we talk about direction? Well, we have two different notations for vector directions. Magnitude, of course, is the length of the vector, and we give it a certain number. So 5 meters, we might say, or 0.5 miles. That's your magnitude. But with regards to your direction, there's two different naming conventions that we have. One of which is a little bit longer, but it's more descriptive. The other one is shorter, but it kind of requires you to think a bit about it. And I'm going to call this first one the x, right down the bottom right here. I'm kind of running out of space. The x-axis notation, and I'm going to call this the compass notation on the right-hand side. Okay, so let me switch to blue right here. All these blue lines, let's say, are vectors. Okay, so the black lines are our x and y. Oops, I'm doing that in the wrong spot. Are our x and y axes. All right, but these blue lines are vectors, and so that's indicated by the arrowheads right there. So we would say this vector is we're going to measure it from the x-axis. In fact, all of our vectors are going to be given some sort of an angle measurement from the x-axis. It may not be the closest axis. It may be that this vector is drawn closer up here, so it's closer to the y-axis. It doesn't matter. We're going to measure it. Our x-axis is our reference point. All right, so this actually looks kind of like 45 degrees, and so I'm going to say it's 45 degrees. And the naming convention we're going to use is this: 45 degrees above the positive x-axis. Okay? Here's the positive x-axis, here's the negative x-axis. Positive x-axis, and so it's 45 degrees above that axis right there. Never mind that it's some angle from the y-axis. We don't care about that. We care about the x-axis. All right? What would this be right here? That would be 45 degrees, what? Below, right? Below the positive x-axis. All right? Again, it takes a little bit more time to write out, but it is more descriptive. This vector right here is 45 degrees, we'll say, below the negative x-axis. And this one right here is 45 degrees above the negative x-axis. Okay? So that's our naming convention with regard to axes. A little more to write, however, it does tell you exactly where it is with regards to the x-axis. If you're more familiar with a compass and you think you kind of get this whole vector direction convention, you can use compass points as well. I'll write them in red. See, north, south, east, and west. We can say that each of these vectors has a certain value with regard to those compass points as well. We might say that's 45 degrees north of east. Okay, so it's, previously we said it's above the positive x-axis. Here we say it's north of a certain degree, number of degrees north of east. So if this is east, east is functioning as the positive x-axis, and so our vector is 45 degrees north of there. All right, what would this be right here? That would be 45 degrees south of east. This vector would be 45 degrees south of west, west functioning as the negative x-axis, and this one right here would be 45 degrees north of west. So a little bit shorter to write, however, it kind of requires you to think a little bit about the compass points. Okay, so that's how we describe vectors, and we give them magnitude and we give them a direction using one of these two direction naming conventions. And for now, I'm actually going to stop right there, and we're going to pick up in the next video with some familiar properties of vectors, how we add them, and some other kind of mathematical properties of them, and do some examples, and then we'll move on to breaking vectors into components. So thanks for following along. I'll see you on the next one.